Yes. Okay. First question. In wastewater treatment system, sludge is produced from four options are given: sedimentation tank, secondary clarifier, C both A and B, and D none of the above. So the answer is, anyone can answer? Yes, both A and B. Right answer. This is the answer. So, how it comes? See here in wastewater treatment plants, as we all know that primary treatment, secondary treatment, and tertiary treatment is there. And here you know that the sludge which is produced. And the question is in wastewater systems, where the sludge is produced from. So in the sedimentation tank, as we know that due to the settlement of the sludge due to the gravity, we can have the sludge in the sedimentation tank. Also in the secondary clarifier system, also after the primary one, we'll get the sludge. So I have just prepared few things which is on the different steps, the process and the sludge produce, so you can read this. And next question, waste activated sludge. That means WAS. Waste activated sludge is produced from four options are given: primary sedimentation tank, secondary clarifier, grit chamber, and none of the above. Okay. So B, yes, right. B. Activated sludge. So activated sludge, waste activated sludge is produced in secondary clarifier, right? So here you see that what is waste activated sludge. It is a byproduct of activated sludge process in wastewater treatment. It consists of, the main point is microorganisms are there, and also microorganism also their byproducts due to their process. So microorganisms that are used to treat the wastewater along with their metabolic waste products. So these are there. That is waste activated sludge. So and I have also given here the what is the composition of waste activated sludge. That is primarily composed of microorganisms. That means bacteria and protozoa and their extracellular substances. And what is the concentration? Typically has lower solid concentration compared to the primary sludge, but can vary based on the treatment process. An oleum generated in substantial quantities related to the oleum of the treated wastewater. Okay, so here you can see waste activated means we have to remember about the microorganisms and their metabolic waste products. Now, arrange the steps for sludge handling in the sequence. So, next question, we have to arrange the steps for sludge handling in a sequence. So, four options are given. So, the processes are drying, thickening, hygienization, dewatering, and stabilization. So, we have to arrange these all processes in a sequence from starting to the ending. So, four options are given. So, you can see this options. See here, and anyone can answer. So you have to start from the initial to final. Hygienization is used for the water. Like if some odor is there, we are removing pathogens are there. We are. It's chlorination can, but also that UV also can come. So okay, I will take that thing in the next slide. So which one? No. Sorry. Yes, C is the answer. Yes. So thickening, stabilization, dewatering, hygienization, and drying. So I will tell you one by one. Here, thickening. So thickening means, like the name itself indicate, that concentrates the sludge by removing a portions of water. Okay, so stabilization. What is stabilization means here? The treats the sludge to reduce the pathogens and odors. Okay, that is the stabilization. Okay, sorry. So here you see that treats the sludge to reduce the pathogens and odors and make it more suitable for handling the disposal. So if you dispose without stabilization, what happens is, like the byproducts itself. So if we treat a water and then we have a concentrated solution, which is not, it is, we have two main product: concentrated solution, and then you also have a water, potable water. So this two we have. So this one we can take it and we can further use, but this one, this concentrated solution, if we directly dispose it, so this, it has a lot of problems. That's what here, this sludge which formed here, we have to do some more steps to remove the pathogens and odors. Also in case of potable water also, as you have seen, after secondary treatment, I told you about the tertiary treatment. So tertiary treatment, anyone can explain what is tertiary treatment? Yes. Yeah. Yes. Other than that one, we can also do the uh, UV treatment, right? So that will actually clear the water to a more, usable manner. Okay. So also you should remember one thing, that what purpose. So we have wastewater here, and this wastewater, how, why we are treating, why we are treating. So is it for the industrial purpose, or is it for the other, if we are not not, you don't want it for the industrial process, you want it for the drinking purpose, or you want it for the, you just want to use it for the agriculture. So according to your, your result that you wanted, you have to fix the composition of different chemicals in the water. Not only chemicals, also if you have a permittable, the, if the microorganisms are there. So if you are just using for the agriculture, is it okay to use, and how much it is allowable limit for the safe usage of that water in that, for that particular purpose, we have to decide how much step we need. So should we need more, clear water, or should we just stop it with this, and we can plant, we can just water our plants. So that we decide according to our end decision that we want to take. So now, if you have a wastewater, and now first concentrates the sludge by removing the first step that we need to proper use it, proper what you say here, you can see that when you have a sludge, you have to properly, handle. So that means, what you have to, if you have a lot of portion of water, the volume of the total sludge will be very high. So that will restrict, you need a big machineries to work with for treating that. So to eliminate that also, that means you are reducing the cost, or you want to reduce the energy consumption, you need to remove the water, so that you are reducing the sludge. So you have this much amount of sludge, then after this dewatering, what you are doing, what the sludge processing, you are making its volume small, so that you can only handle this much amount of sludge. So that's what here it is doing for the sludge handling. So here, thickening, Stabilization means treat the sludge to reduce the pathogens and odors to make it more suitable for further handling or disposal. And then what you have to do is dewatering. So dewatering means it reduces the water content to produce a solid or semi-solid sludge. So then it comes the hygienization. So this means it ensures sludge meets health and safety standards, often through processes like pasteurization and high temperature treatment. Okay, so I have just mixed with the stabilization. See here, the hygienization means you have to meet the from this step we got a sludge here, and we have to look into the safety and health standards for the sludge for the further step. So that we have to either go for the high temperature treatment, or we have to use some pasteurization for the for make it suitable to process for the next step. That means it we have to look into the quality of the sludge here. We should see the quality. So that means like we have to make this quality under the limit for the transfer to the next step. So next is the drying process. Here the drying means the remaining water content to produce a dry and solid product that is easier to manage or utilize. So these all steps involved in the sludge handling. So any doubt in this step or hygienization? Confused, or is it clear? So what is the this pasteurization? You know, so pasteurization means we are heating our sludge to a temperature about 70 degrees Celsius, about approximately I'm saying, for 1 hour, and that will process the remaining sludge and remove um, the it will make our sludge. And we should for even this also, the time period that we need for the pasteurization also, we have to fix according to the this this health and safety standard. So if you want for different what you are using for the end sludge, where you are using, according to that we have to fix the pasteurization time, and the heat treatment also we have to fix accordingly. So any doubt in this step, hygienization? Also there is one more thing is there here. I hope its name is radiation also we can provide. Clear? Is it confusing or? Okay, sorry, I didn't know that I have left the meeting. So till what I was teaching you, people were there. Thickening only. Okay. Okay. Okay, sorry. Okay. So here we are starting with thickening of the sludge, then stabilization comes. So here the stabilization means the sludge that is produced is they it may have pathogens and odors, where to make it suitable for the further handling and disposal we have to reduce it. For that we have to go through the stabilization step. And then dewatering is simple, that we are reducing the water content to produce more solid and semi solid sludge. So next comes hygienization. So what is hygienization here? It so we know we have to first see the health and safety standards for the sludge produce to make it safe. Okay. Okay. Okay, now you can see, right? Okay. So hygienization means here we can either go for pasteurization or high temperature treatment. So what is pasteurization? Yeah, so the process is we have to heat the entire sludge. So the approximate I'm saying approximately 70 degrees Celsius, we are heating the sludge for 1 hour. So also other than this pasteurization or high temperature treatment, also we can go for radiation. So radiation also we can use for the uh, hygienization step. And the last step is it is for removing the water, remaining water content. If some drops are somewhere, it is, if in the pores it is trapped, then final drying process can also enhance this, removing almost all content in the sludge and make it more solid, or it make it more easier to manage and utilize. Is it clear? Sorry. So see, here thickening means it is initially it is starting with the thickening process. So for the thickening, there are different mechanical thickness are there that we comes in the further slides. So that will remove a part of water. Then it comes for the dewatering. So dewatering has some other equipments which will again squeeze out the water. So it will come. Yes, yes. Yes, in both cases, water is being removed. Even here, thickening, dewatering, and also drying. In drying, the final water content is removing. Okay. Okay, so I think in the further slides, I have explained about different dewatering things. So I think that time you will be get clear. Otherwise, end of the class, we'll come back here. Okay, you just remember this step, and I have some more slides on this steps. So have you guys already seen the lectures? Okay. So the next question, the organic fraction in the sludge solid is indicated by. So organic fraction in the sludge solid is indicated by, four options are given. So in the ratio of solid to total sludge volume, also ratio of volatile solids to total solid, then also ratio of total solids to total water content, and ratio of volatile solids to total water content. So the organic fraction in the sludge solids. So the answer is this one, volatile solids to total solids. So I will explain here. So what is the organic fraction? You know that in the sludge we have organic and also inorganic contents, right? So here the question is organic fraction in the sludge solid is indicated by different ratios they are given, and how can we represent it. So here see, you see organic fraction in the sludge is indicated by the ratio of volatile solids to the total solids, because here volatile solids represent the portion of sludge that is organic and can be decomposed by biological process. So here you can see that why this volatile solids have come. So that means it represent the proportions. Volatile solids means it represent the portion of the organic portion of the sludge. Have you seen the lectures? Okay. So here, organic solid, these are the solids in the sludge that can be burned off when heated, which primarily includes organic matters like proteins, fats, carbohydrates, and other organic compounds. That is the volatile solids. So total solid means this is the sum of volatile solids and non-volatile solids. So volatile means what? Volatile means it become volatile, like become. You know what is volatile? I'm sorry. I think there is some connectivity issue here there in my campus. So, if so, till what you people were there. I'm sorry. Yes, can you hear me? Yes. Huh. Okay. That. Yeah, yeah, yeah. Anyone can like tell this. So anybody else also experienced this? Okay. Okay. So have you tried in incognito mode? So this mode. So anyone has the same experience now? Sorry? No, no, like okay. Okay. I think incognito mode it may work, right? Same mode. Okay, okay. Yeah. So you can try like that. Yes. Okay. So for this slide, like till what you people were here? I'm sorry to. Okay, only that one. Then next question it is okay. So this question also it was not. Uh, okay, sorry. Like I thought I was teaching. Okay, so Okay, now the organic fraction in the sludge solid, it is indicated by four options are given. So here, uh, total solids and total sludge volume, or altai solids. See here, solids, total sludge, altai solids, total solids, and total water content of the sludge, altai solids to the total water content of the sludge. So, which ratio is indicated by the organic fraction? Sorry, this one, right? Altai solids. Yes, this is a right answer. Yes. So why it is like that? So here I have explained about the volatile solids and total solid. What is meant by volatile? Volatile means become, it changes state of being. So here volatile solids, these are solids in the search that can be burned off when heated. So when we apply the thermal energy, it will get burned off and it will transfer its state. So here the which this particularly include the organic matters. So organic matters like proteins, fats, carbohydrates, and other organic compounds. So when these, portion is getting the thermal energy, it will convert into the another state. That is the organic solids in the sludge. And then total solid in the sludge means this is the sum of both volatile solids and also non-volatile solids. So that means here this is the total solid content in the sludge. And when we apply the heat energy, that means thermal energy, a portion of the total solid get converted into the voltage state. So that means that portion is mainly of these things which I have mentioned here. So when we take this ratio, volatile solids represent these things: proteins, fats, carbohydrates, and other organic compounds. So this represent this one, and divided by total solids. Okay, so this one, when we apply thermal energy, it get fully burned off and it convert into the gaseous state. And here, what happens here, this volatile solids are there, also non volatile solids are also there. So we, when we take this fraction, and this is called organic fraction in the sludge. Organic fraction, okay, here it is mentioned here, organic fraction in the sludge is this one. And here, so if we see that this ratios, if you see this ratio is very high, so that means, see here, a higher ratio indicate a greater volume of organic material, which is important for understanding the potential of the biological treatment as well as potential for energy recovery or nutrient recycle. What do you think that we need more volatile? What do you think that if we need of this volatile solid more in the sludge, is it necessary? Anyone have any comment on this? Yeah, why it's so, like, from this, yeah, this is organ, it is a, yes, how it, yes, 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 this is important. And also we have the energy required, that means for the electricity production or micro, that fuel cell, we need the content of organic, volatile, volatile, this volatile solids in the sludge is important. So that is clear. This, sorry, yes, waste energy plants also, this is important, this, right? I didn't get you, sorry. Yeah, yes, 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 yes. Or that is only this organic fraction, this ratio we have to calculate for that. For the we can even predict the operational success of the system. Now, sludge thickening leads to four options are given: reduced water content of the sludge, increase solid content of the sludge, reduce total volume of the sludge, D, all of the above. The sludge thickening. So, sludge thickening leads to what? Yes, all of the above. All of the above is the answer. So reduced water content is there, and also we have the total. When we see the solid content, also we have the proper solid content in the system is higher, and also reduced total volume of the sludge. So as you see that when we remove the part of water which is in the sludge, we are actually reducing a huge volume of the total sludge. So here, sludge thickening, it is a step in wastewater treatment that concentrate the solids in the sludge. This leads to several. Here you can see there are different advantages and benefits for it that I have explained. The cost is there. We are reducing the cost. Also, we are reducing the energy consumption. If we have a higher volume of the sludge, then we need higher energy to treat the sludge. If we have a lower volume, it is easy to handle, thus the energy consumption also less. So what are the things that we are using for the thickening process, thickening of the sludge? So these are the different thickness. One is gravity thickness, dissolved air flotation, rotary drum thickness, belt filter thick press, screw press, decanter, centrifuges. So here, anyone heard of these things? Yes. So it is simple. Here, gravity thickness, utilize gravity to separate solid from liquids. And here you can see here, this is the gravity thickness. You see, this is the sludge in. And then here you can see this is the outflow. And here uh, you can see that the whole system is in the in the vertical direction, where the we have a lot of cross sectional area where the gravity can act, pull up, it can separate the solid content from the sludge that we are going to process. And sorry. Yes. Can you explain about that process you are saying? Mm. Yes, yes. Yes, that is also an important step. Yes, yes. I have heard about. Yes, yes. So you can add the chemicals also for the step. And here that is the mechanical things that I am explaining about, the mechanical instruments that is used. Yes. So next is dissolved air flotation system. Here you can see uses air bubbles to float the solids to the surface. That you can see here, the air flotations are there. It will trap the solids, and it will it will transport the with the bubbles, it will transport and we can separate. And then rotary drum thickness, so that you can see here, sludge in. And then here you can see that see this, you can see the shaft in the system. So when we put the sludge inside, and this shaft will rotate, and it will when it rotates, it will actually trap this solids. And when we move in the horizontal direction, we see that the thickened sludges in the away from the inlet, and this we can separate separate it out from the system. And this one, when it pass also, there is filter is there. If there is lower, the sludge, if the water content is more, this water content can come out through the filter, and it is it is we can take out in the lower compartment, and the sludge will go move towards the outlet of the section, which it can't flow through the filters, so that we can separate it at the end of the shaft. Then belt filter press. So here you can see this pressing chambers are there, so the water will flow, and then you can see there is a pressure applied in between the sludge. So that means, have you what system I can tell? Okay, you know about the rubber plantations. Yes, so in that rubber plantations, like we take the latex, and then to make it the sheets, what we do, we use a machine to squeeze it out the water. So I hope that you guys have seen that. So it is similar that it we are applying a pressure between the sludge. That means it will uh, give force to the sludge and skew. It will take out the water that we can collect, and the solids we can separate it like this. And then screw press, the screw to compress the sludge and remove the water, that you can see here, the screw grooves you can see. So this also, you can see this will, the inlet we provide, inlet sludge is here, then screw systems are there, and then what you happens is the movement of the sludge is through this, and because of the presence of screw, it will take out the sludge, which will trap on the screws, and the water will flow through it, through these part, and then the water is freely flown, and we can separate in the outlet. And then decanter centrifuge, that means spin sludge to separate the solids from the liquid, that you can see here. This is the centrifuge. So due to the centrifuge force, the centrifuge force will act on the sludge. That means the sludge is the solid particles, it will, we can trap it in the outward peripheral area, then we can separate. Got it? Yes. Okay, so then these are the advantages. So increased solid concentration, reduced volume, improved efficiency, cost savings, and enhanced treatment. So initially we are dealing with this much volume, and we have water also inside its content. Now after the process, we are dealing with the smaller volume, which we can process it easily. Next question: the different fuel based sludge use options are: A, incineration; B, supplementary fuel for power; C, gasification; D, all of the above. Yes, right. So what is incineration? Yes. Yes, heat, very high temperature. So you can see, okay, this is, so you can see the incineration means we are handling the sludge. Here we have to burn the sludge at very high temperature. Can you guess what is the temperature will here in incineration? Yes, 105. Yeah, yes. So here incineration means we are the system is at very high temperature. And then supplementary fuels. So why supplementary fuels are used here? Sorry? Yeah, here that means in incineration means we are using at a very high temperature. You are right, but when we have more organic and it, if there is some water content is there, the burning efficiency is less. So to increase proper burning, we are supplying some fuels also, for the proper burning of the entire sludge. Got it? So, for example, I can't tell you an example. So, see, if there is more water content in the system, so if we are in the system, the temperature is 1050 degrees Celsius or above, also, the burning happens. But if you think about, we need more efficient burning, then if we add slightly some fuel also inside the system, it will burn efficiently than uh, without applying any fuel. So that's what supplementary fuels. If we apply some supplementary fuels, means like some biofuels or waste derived fuels, or industrial byproducts. So if we apply something like reusable fuels or environment, so here the biofuel means, it is, we can say that it is more bio environment friendly. So you know that some wood chips, straw, or agriculture waste. So it is very simple that if you think about a diaper is there. So if we have a diaper and if you heat it, it may burn little bit, but it don't burn that much efficiently. But you just put some wood, or if you some paper or something on it, and then if you again burn it, it will burn more efficiently than the first case. So that was happening in the supplementary fuel addition into the sludge system. Okay. So then, gasification of sludge. So here what is the uh, the sludge is in a compartment where it is having a low oxygen atmosphere also, low oxygen, and then we are burning into the high temperature. Sorry, which one? Yes, the gasification sludge is a you means, is this the digestion process you are asking? Yeah, it is a kind. Yeah, it is a kind of. Yes. You can, yes, you have, see here. What is the difference you can see here? Digestion and dewatering. That will come. So gasification I have explained, and then sludge in this you can see in the slides. So here, digestion and dewatering, the difference. So here, main purpose of digestion means it is stabilize and reduce the organic content. And dewatering means, see, in dewatering we can see it is more of reducing the water content in the solid concentration. That means in the sludge. So digestion has more of, reducing it, the organic content. So as you say that here, when we burn it, the organic content is reducing in gasification, right? Clear? Yes. Yes. Yeah, yeah. Yes. 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 Yeah, both are different. So as I explained you in the, see, in the sludge thickening process, we have to thicken the slides. So here you see that dewatering is there in between the step when we handle the sludge. Okay. So dewatering is there, But also we need to stabilize also the whole sludge. So after the stabilization, we can, if if some water content is there, we can de-water also from the system. Not clear. Okay. So here, you can read this difference between this both digestion and dewatering. Yes, 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 sure. Yes, yes. Uh, which one yours? The Yes, yes, centrifuge. This one. Yes, yes. Yeah. So yes. Mm-hmm. No, no. Cost comes, and also how much is there, the solid content is there. So in the gravity, that if the weight of the sludge is more, then we can separate it easily. So but when the weight is little less, then or also it may flow through the entire the system, then this dissolved air flotation will be, it will, we have the air bubbles, and then it will float to the it will take away the solid in the system. And also, yes, yes, oily, yes, 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 oily, it is mainly for the oil industry it is used, yes, right. And also that means like the type of sludge that we are using, sludge that matters, the density also matters, and then the cost comes, then energy consumption also comes. For different, I don't know about energy consumption of this separately, I don't know, but energy consumption is also an important factor. So energy consumption for different mechanism, it is different. So all these things will matter. Okay. 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 Yes. So yeah. And also, as you said that the oleum that they we have to treat, so that also matters. Yes. So in what industry you have shown, in what, so in that also what type of wastewater they are dealing with. Okay. Okay. Okay, okay. So for that it may from these all technology that something more suitable. I don't know which one is more compatible with that water, but it depends on the the type of sludge also we are processing. That will matter. Okay, then that would be. But as you Sangamita have told that this one it is mainly for the oil industry. So like that it may differ, that's all. Okay. 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 Okay, let's move to another question next. So which of these example of mechanical thickening device are used for sludge? Dissolved air flotation, sludge centrifuging, screw press thickener, both B and C. Mechanical thickening device. Yes. So mechanical thickening device, which is sludge centrifuging and screw press thickener that I explained, have shown here. This screw. This is also mechanical one, and this is centrifuge one. Centrifuge. Okay. Okay. So I have explained about this mechanical thickening device. So you can read it out, and then um, anaerobic sludge digestion is the process where the digestion take place only in the mesophilic temperature range. B. Similar to activated sludge process. C. Organic matter is chiefly converted into biogas. D. All of the above statements are true. Sludge digestion. Anaerobic sludge digestion. Not A. Not A. Yes, right. C is the right answer. Organic matter is chiefly converted into biogas. That you can see here. Or anaerobic sludge digestion, it is where the microorganisms are there. It will break down the organic matter in the sludge in the absence of oxygen. This process is used to stabilize and reduce the volume of sludge and is also generate biogas, as you already know, that is methane and carbon dioxide. So these are the different steps that you can read it out from here. So next question, sludge hygienization is the process to remove pathogens and odor and is necessary before land application of sludge, incineration of sludge, dewatering of sludge, all of the above. Yes, land application is the answer. Yes. So like that, which I explained, if the sludge that you going to deal with, what is the end requirement that you need? So accordingly the steps will vary. So here, um, before land application of the sludge, we have to go for the hygienization process. Sorry. So why we need this sludge hygienization? It is treating the sludge to reduce, eliminate pathogens, parasites, and other harmful microorganisms. Uh, so before disposing into a land, why we need this process? So it is very simple that if you just dispose like this in the open land, open landscape, what happen if the open land is there and then we are directly disposing the sludge here, and yes, yes, pathogens, and what it does that it will also affect the, yes, 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 area is contaminated. Area contaminated, also the groundwater pollution can also happen. Also, if some water bodies are there, and if some rain, the runoff also can happen, and then it will go to different regions nearby. Also, it can transport to a large distance also, and it will affect the ecosystem. So that's why, like, we need sludge hygienization before disposing the sludge into an open land. That you can see, different sludge hygienizations are there. Thermal treatment: burn the sludge at high temperature, effectively killing the pathogens and reducing the volume of sludge. Then pasteurization also, that I have explained, it will heat the sludge to a very high temperature and kill the pathogen. And here you can see chemical treatment also we can apply. And then biological treatment is there, and solar drying and composting. So among the steps that I explained here, what do you think, which is the lowest cost and easy way? Sorry. So we can see different treatment of this high sludge hygienization: thermal, chemical, biological, solar, and composting. Among this, what do you think that it will be easy to you process, low cost, lower energy consumption? Yes, solar drain. Yes, yes, yeah. Chemical, then cost is there. Yes, high cost is there. Samples can be required, and yes, yes, yes. Yes, solar drying is the easiest way that we can use for the sludge hygienization. Then, sludge digestion is a process for reducing water content of the sludge to recover metals and nutrients from the sludge, reduce solid mass by decomposing organic solids, and D, all of the above. Sludge digestion is a process for, sorry, which one? Yes, yes, yes. Reduces solid mass by decomposing organic solids. You can see here sludge digestion. So here the sludge digestion is a process used to stabilize and reduce the volume of sludge produced in the wastewater. Here you can see the primary goal are to break down organic matter and reduce odors and convert the sludge into more manageable form. So mainly here you can see two main type of sludge digestion: aerobic digestion and anaerobic digestion. Here aerobic digestion means we have the presence of oxygen, and here anaerobic means here in the absence of oxygen. Okay, absence of oxygen. You see the sludge is exposed to air, which is having a good amount of oxygen in the aeration tank, where microorganisms break down the organic matter. And then you can see anaerobic digestion: the sludge is decomposed by microorganisms in the absence of oxygen. This process occurs in digesters and produces biogas. So you know that what is biogas. Here methane is there and carbon dioxide is there as the byproduct. So sludge digestion is mainly used to process the solid mass by decomposing the organic solids in the sludge. It is used to reduce the volume of the sludge by making either by aerobic digestion or anaerobic digestion process. Okay. Any doubt? Okay, we'll start from next question, like within 5 minutes. 5 minutes. Any doubt till here? Okay. So we'll start after 5 minutes. So we have some few problems and uh, yeah. So after 5 minutes we'll start. So we'll start the problem. here the water content weight by weight of 5000 kg wet sludge is reduced from 99 percentage to 95 percentage. Okay, what would be the total weight of thickened sludge? Okay, thickened sludge, we have to find thickened sludge weight. So the data that it is given, water content of 5000 kg wet sludge. So now we'll start with, I'm writing the steps. First step, what we have to calculate is we have to calculate the um, dry solid mass in the original wet sludge. Dry solid mass in the original wet sludge. You got it? That means what it is mean. So we have sludge. So in that sludge, we know that, let's say this dots denotes the dry dry part, that means solid part, and then remaining area that you can see have the wet, that means water content is also there around it. Okay, so this dot denotes the solid. So we know that the we have to find the dry solid mass in the original wet sludge. So this is the wet sludge, the total weight, this is the total, and then from this system we have to find the weight of the dry solid mass. So we have to find the weight of the total solids in the system, that means total mass of this dots in the system, that we separately we have to find. Then what we have to do is, then we have to calculate the total mass of thickened sludge. So first we have to go to this step. What is the dry solid mass in the original wet sample, wet sludge? The whole sludge, what is the mass of this dots, the solids? So first of all, what is the condition it is given? Here it is given the wet sludge is reduced from 99 percentage to, see here, water content of 5000 kg wet sludge is reduced from 99 percentage to 95 percentage. So here you can see from this particular thing, you see this is initial and this is the final. So initial is 99 percentage wet. So here this statement means initial water content. What will be the initial water content? 99 percentage have water content. Then from this particular value, what you think, what is the solid inside? So this statement means the this space, this, yes, 1 percentage. So here you can see in this figure the dot, this means nine, the empty space that I have, so you can see in the figure, means water. So here the statement is given 99 percentage reduction in the wet sludge, sorry, 90, from reduced from 99 percentage to 95 percentage. So initially it was 99 percentage wet. So that means this portion, which is empty portion, this is 99 percentage, and then these dots which I represent, this is only 1 percentage of the total system. Now initial mass of the wet sludge, initial mass, mass wet sludge, that means it is 5000 kg. That means the initial mass of this whole system, this one which I draw, the total mass is 5000 kg. Okay, from here you can you calculate what is the mass of the solid and what is the mass of the wetness, I mean the water content. Yes, what will be the, yes, this one, remaining. Yes, that means 5000. This not, you can just calculate this. Okay, 4000 for 950, right? So here you can see that 50. How did you calculate this? 5000 into point 1, 0.01, right? Any doubt till here? Any doubt? No doubt. So you this portion is clear. I hope this here we calculate the mass of the solid, which is this dots which I just represent here. That is 50 kg, and the remaining whole portion is 4950 kg. So that is from the statement we got. The initial wetness of the sludge is 99 percentage. That we got it. Now what is, now it is given the water content of this total sludge is reduced from 99 percentage to 95 percentage. The final is 95 percentage. Final wetness is 95 percentage. So what would be the total weight of the thickness sludge? So here what you say, this is the first state. This is the first state. Here you I and here the 99 percentage wetness, the total sludge, then finally it will become 95 percentage. So here it is 95 percentage. Here also mass of the solid is there and mass of the liquid is also there. So here the question we have to calculate the total weight of the thickened sludge. Total weight, what is the total weight of the sludge? That is the question. Okay, now for that what we have to do, so here you can see that after thickening, so the total water content is reduced to 95 percentage, right? So this means what will be the solid percentage? 5%. Yes, yes, 5%. So now you can calculate total mass of thickened sludge. So this one, how do you calculate? So total mass of thick sludge, you know that the thick sludge mass, that means which the percentage is 5 percentage, that means 0.05, right? Which is, we got the answer. What was the thickened sludge? 50 kg. So now mass of the thickened sludge is equal to 50 by 0.05. What is the answer? 1000 kg. So this is the thickened sludge. So you this is the so so the question is, okay, you need to calculate total weight of the thickened sludge. So only thickened sludge we need to calculate the mass of the solid that we have to calculate. So we have calculated is 1000 kg. So the answer will be A. Any doubt? We don't need to calculate the full weight. We have to calculate the mass of the um, solid in the final sludge. Any doubt? Any doubt? No. Okay. Got it? Everyone got it? Okay. So we go for any doubt? Okay. So now uh, the simplest method of dewatering is by using centrifuge and belt press, sludge drying bed, and then thermal treatment. Simplest method. Yes, right. Why? How can we say that? It is simple, easy. So, like all other things need, see, the centrifuge and belt press, the mechanical instrumentation is needed, right? And then thermal treatment also, you need high temperature and you need some specific compartments and all. But here in the sludge drying bed, you're just, keeping your sludge in a bed, and then what is happening? It will just evaporating, and we can just collect the what if you want, you can collect the water, or else you can separate the sludge. Got it? Yes. So here dewatering is the process of removing water from the sludge or slurry to reduce its volume and make it easier to handle, transport, or dispose of. So I have given different methods of dewatering: centrifugation, belt press, filter press, drying bed, screw press. So here you can see this one. The first one is here centrifugation. You can see the rotation of the mechanical part here, and then second is the belt press. So this is the belt press. This is the first one, centrifuge, and this is the belt press, and this is the filter. Yes, filter press. Third is the filter press, and then drying bed is here. You can see it is just, we are just putting the sludge here, and you can see the um, here the drainage water to here you can see this is the outlet. So here you can collect the water even from the drainage. By the drained of the water also you can take. This is one method. Also evaporation also you can do it if there is enough solid raises there, or else you can make the system such that the water content we can collect from the down compartments. Drained water you can collect it from the down compartments. Then screw press, this one as previously explained. Okay, got it? Okay, next question. The thickened sludge, any doubt? Okay. So the thickened sludge received from secondary treatment with a total dry solid mass of 3088 kg per day is to be digested in a standard anaerobic digester. The sludge is 70% organic and 30% inorganic. During 30 days of digestion period, 60 percentage of organic fraction is converted to liquid and gaseous products. So the digested sludge has a solid content of 5 percentage weight by weight. So based on the above information, what is the total mass of dry solid remaining after the digestion? So what is the total mass of dry solid? So here also we have to find out the mass of dry solid after 30 days of digestion period. So how do you first calculate this? So we have to find the total mass of dry solid after 30 days of digestion. So you have to first start with, first you have to find the mass of organic and inorganic solids, mass of organic and inorganic solids, mass of organic and inorganic solid we have to find out from the statements. Then what you have to do is you have to calculate the um, amount of organic solids, amount of organic solid, that is here convert to liquid and gaseous, amount of organic solids converted converted during the digestion process. Then third we have to calculate the remaining organic solids, calculating the remaining organic solid. Then this statement means remaining organic solid after this 30 days of digestion period. Then fourth one we can calculate the total mass of dry solid, mass of, we have to calculate we can calculate the mass of dry solid. So first of all we can start with the this one, mass of organic and inorganic solid. So how we can see here, from the secondary treatment with a total solid mass. So total solid mass 3088 kg per day. So now the sludge is there. The total dry solid mass is 3088 kg per day, and then another information is given. The sludge is 70 percentage organic and 30 percentage is inorganic. So from this statement, can we find the mass of organic and inorganic solid in the system? How do you calculate organic to, yes? So how did you calculate? Yes, yes, 3088 into zero point 0.7. That is the mass of organic. Then what is the mass of inorganic? Yes, this is 9 to 6.4 kg per day. This was 21, right? 2161.6 kg per day. So we got first one from the first statement. We have the total mass, and also it is given from that sludge 70% is organic and 30% is inorganic. and the percent from these percentage and the total mass which is given, we can calculate total sludge percent and inorganic also. So that we calculate organic, that means organic here means that is 70 percentage. So this 70 percentage means we have calculated 2161.6 kg per day. And then this one which is 30 percentage inorganic, we have calculated 9 to 6.4 kg per day. Till here it is clear, I hope. Now we have to calculate the amount of organic solid that is converted in the digestion process. So that also given. See, during 30 days of digestion period, 60 percentage of organic fraction is converted to liquid and gaseous products. It is given 60 percentage of organic fraction. So 60 percentage of organic fraction is converted liquid and gas products. From here we can calculate the mass of organic solids which is converted. So mass of organic solids convert to converted what, converted to gaseous state, liquid and gaseous products. So that means what, it is given that 60 percentage, 60 percentage of the organic solids. So we already have the mass of organic solid. This is organic solid was 70 percentage, and we have calculated 2161.6 kg per day is the organic, this organic solid mass. So here we have this amount of mass, and it is already given 60 percentage of the organic fraction is converted. That means what, 2161.6 into 0.60 percentage of organic. See, from the total organic solid, 60 percentage is converted to gaseous and liquid products. So that means what is the what is the value? Okay, 1296, right? 96.96 kg per day. That means this is the, so we had the system here, 70 percentage, 30 percentage, and this is organic. And here we have calculated the organic was 2161.6 kg per day. Then it is given that from this particular organic fraction, 60 percentage is converted to gaseous and liquid. From this 60 percentage, we have calculated 1296.96 kg per day. Yes. Sorry. Yes. So yeah, as per the answer, I'm so what is the, you tell me the final answer, then I will tell you. Yeah. Okay, reduction. Hmm. Okay. So so you, okay. Okay. So I am solving according to the answer which is given in the booklet. Answer is given in the booklet, then I have, so like this way, then I'm matching with the answer. So let me, so what is the answer you are getting? Last answer? So that will come. Yeah. So okay. So you have directly calculated that. Okay. Yes. So here this will covered. Yes. 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 Yeah. So then, yeah. Sorry. Yes. 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 I can hear. Yes. Now, what do you have to do? Okay, we will solve it and find out. Like you, what is your like? You have directly put 40 percentage and got the final answer. Yes. Okay. Ah, okay. So it's fine that this one. Yes. Yes. No, here na. So this we can use. So this whole information is for the questions from 13 to 15. Okay. So here we can for the first question we can consider only till here. Okay. Okay, let's move and I will find out. Like, so what you said is like what you have calculated is also 40, that is right. Then you have directly calculated. And then here you can see I have written calculating remaining organic load. So that means that I am, subtracting the value. Yes, okay. Okay, then this one is total or solid that is converted, that we got it, and the remaining organic solid. Remaining organic solid means how do you calculate what you have? You already have the total organic. Yes, remaining after digestion. That means we are just two one. I think two one. Right. Yes, 2 1. I have calculated here. 2161. 2161.6 minus 1296.96. What is the answer here? I will same, right? 860. Yes, yes. Wait. 864.64 kg per day. And then the question is we have to calculate the total dry solid mass remaining after the digestion. So we have to calculate the total. So total means what comes? This will come 864.64 plus what else can come here? Yes, that means that is inorganic. 926.4. That means 1791.0. Okay. 4 kg per day. So this is the total. Yes, this is the total mass of the dry solid that is in the system after 30 days of digestion. So now, okay, let's solve this all problems from 13 to 15. Then we have some discussion on this. So now second one is what is the digested sludge oleum accumulation rate assuming a specific gravity of digested sludge is 1.01 meter cube per day. Okay. So how do you approach this? So now we have the values for the total dry mass of the solid in the sludge that we have. And then we have to proceed. What we have to calculate is, we have to calculate the digested sludge oleum accumulation rate, in that is also in meter cube per day. So that we have to calculate. For calculating this, first of all, we have to calculate the digested sludge oleum. Okay, digested sludge oleum we have to calculate, and first we have to start with the, yes. So first we have to start with the, uh, okay, first we will write the answers that we got in the previous step. Okay, so first of all, what we got is, we got the total mass of the dry sludge. That means mass of the dry sludge after 30 days of digestion. That means we got 1791.04, 1791.04 kg per day. And then we have to see this one. The digested sludge has a oleum, has a solid content of 5 percentage. Okay, digested sludge has a solid content of 5 percentage. So here we have to write the statement. That means the digested sludge, this has 5 percentage solid content. Okay, now, so what is this meaning? This means that this 5 percentage of total digested sludge mass is dry solids. Okay, so now we have to calculate the total mass of the digested sludge. So what will be the total mass of digested sludge? So we have to calculate the total mass of the digested sludge. It also has the wet sludge. This is the wet sludge. Okay. How do you calculate? We already know that the solid content is 5 percentage. Solid means solid content is 5 percentage. So now what you can say that, so mass wet into 0.05 equal to total dry solids. And now we have this total dry solids. So what is the total dry solids here? So this is the total weight of the sludge. From that sludge, it is given 5 percentage has the solid content. And this solid content we have calculated. We already calculated the total dry solid. What is this value? This one, total dry solids. Total dry solids, here we have calculated this after 30 days. The total dry mass of the total dry sample is 1791.04. Now we can calculate the mass of the wet sludge. Then what you do, 1791.04 divided by 0.05 equal to 1791.04 divided by 0.05. That means 35820.8 kg per day. Any doubt till here? No doubt. Okay. So now this we have calculated the total mass of the wet sludge. Now we have the converted mass of digested sludge. Now, okay. So here we have to convert mass of digested sludge to oleum. So oleum, you know that. So you know that density is equal to mass by oleum, right? So then we have oleum is equal to mass by density. And here we have mass. What is the mass here? Total mass of converted digested sludge. Masses we have calculated 35820. 35820.8 that we have. Then we have to density, we can take like density of water. What is the density? Here you can calculate like specific gravity into density. Then how, what will be the answer here? It is given, the specific gravity is given. What is the specific gravity? 1.1.01. What is the density of water? 1000 kg per meter cube. And then 1.1 is the gravity. Okay. So then what is the density? What is the total density here? 11010 kg per meter cube. Then this value we can put it in this equation. Volume is equal to mass, we have no 35820.8 divided by here 1010 kg per meter cube, and this is kg per day. So how do you, so dividing this 35.47 meter cube per day. So this is the sludge oleum accumulation rate. Accumulation rate. So got this. So in this first equation it is given the conversion, the sludge is 7, so here it is what we have calculated here till here. We have got the value of the organic fraction which is converted to the liquid and gaseous, and this value we know. And then the percentage of this digested sludge is given, that we are comparing with the previous answer. From that we are getting the total digested sludge solid content there, and then that particular value here we are converting into the, what we are converting into the oleum by dividing with the density, which is we take like specific gravity into the density of the water. Clear? Yes. Yes. Okay. Okay. Now, next question. What is the required digester volume considering HRT equal to SRT is equal to 30 days in meter cube? So here, just 1 minute. So now we have to calculate the digester volume. Okay. How to calculate this? So we have to calculate the volume of the digester. So volume of the digester, we can calculate like sludge sludge volume accumulation rate into HRT, hydraulic retention time. So here we already calculate the sludge volume accumulation rate, right? What was the value? 35.47. 35.47 meter cube per day into, this means 30 days. 30 days. So from here 35 yes 1064.1 point 1 is there. Okay, 30, right? Point 1 is there, right? 35.47. Okay, 1 106. Okay, 1 meter cube, right? This one we digested. Okay, got it. Yes. Okay. Okay, here. So this question need to be explained more. No. Any doubt? Anything? Yeah, yeah, yeah. Okay. Yes. Okay. 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 Yes. There they have calculated depth like that, like cross section area into depth. Yes, yes, now it's meter cube. Yes. Okay. So that means the specific gravity. So that as far as I can understand, the specific gravity comes here. The liquid is there, also the part of solid is also there. Yes. Yeah, I hope that fly ash plus the water content. Water. Yes. So the total specific gravity of this one, and then multiplied with the density. But I will answer that in. I can't tell you, like, I will tell you. Yeah. Yes. Yeah. Here, see, you see the specific gravity of digested sludge. Total digested sludge. Sludge. Yes, the sludge. The sludge has water also. The total specific gravity, it is given 1.01. Yes. So, as far as my understanding, I'm thinking like the sludge there, it is fly ash plus water. That specific gravity is there for X. Then you are multiplying with 1000. I hope. Like, sorry, 1000. Yes. Sorry. Okay. 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 So what was the that it region, or what is the examination report? Okay. 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 Mm-hmm. Yeah. Okay. Okay. So the fly ash is from the burning of some agricultural field, right? Power plant. Yes. Okay. Okay. Mm-hmm. Huh. Okay. Mm-hmm. Okay. Okay. Yes. Total cross section area. Then depth you may have calculated, right? Yes. Okay. Okay. Mm-hmm. Okay. Okay. So, got it. Your point. I got it. Like here, the yeah, here the separately we are take, and then we are considering the water, and then total specific. Okay, that I will. Okay, I'll also search and clear this thing. Yes, fly ash. Yes, yes. Okay. Huh. Water. Yeah, that's what my understanding. According to the question, also it is like that. Huh. Yeah, I will also clear this. Yeah, next week. Yes. Anything else? So here also I would like yeah, sludge digestion also. Here I have explained this aerobic and anaerobic digestion. So this in sludge digestion also thermal process also can come. Okay, so that is also there. Then, so any other doubt? No. Sangamitra, like this explanation is fine. This one, the problems. Okay. Okay, fine. Then today we'll end the class. Yes. Thank you. Thank you. Thank you.